Hello everyone, welcome to AWS Tutorials. In AWS Tutorials, we provide workshop and exercises to learn about AWS services. These workshop and exercises are published to our website aws-dojo.com. Today, we are going to talk about using Redshift Spectrum to able to access S3-based data in Amazon Redshift queries. So let's go about it. So in a very short introduction, and that's exactly what Redshift Spectrum does, is that you can use Spectrum to query data from Amazon S3 in Redshift. So when you use Redshift, you generally create a database and tables inside Redshift, views inside Redshift, and you can query it. But if you have some data in S3 and you want to query the S3-based data into your Redshift queries and also able to make join with your Redshift-based tables or views, then you need to use Spectrum for making such query all the way to S3-based data. So that's exactly what Redshift Spectrum does. So what are the use cases? Why I want to query data from S3 into Redshift? Okay, so what are the use cases for such query? And I will talk about two major use cases, and there could be things beyond it. I have no doubt about it, but two major use cases I have seen. I'm going to talk about that first. The first one is that generally I have seen scenarios where people will have two data sets. So for instance, they had some kind of data which they kept inside S3, which is kind of a very detailed data, row level data, transactional data. And then they create some kind of aggregated view about the data in Redshift. So they take this data and then they write some kind of glue job or other methods to aggregate data, and that data they create inside Redshift. And then they are making query on this aggregated data. So, or query could be to create reports or dashboards, things like that. Now, what happens in such case is that for aggregated data, the query goes to Redshift. But when do you want to drill down? That means you want to see the say calculation behind some aggregated data, then or rows behind or details behind some aggregated view. There, in that case, they go all the way to S3 data. And this is interesting one because in this case, you don't need to move your detailed data inside Redshift for any kind of drill down. You can keep your detailed data inside S3, aggregated in Redshift, make your aggregated query in Redshift, but any drill down query goes into S3. This is one scenario which I have seen a lot. Another scenario which I have seen is storage optimization. So even if you're keeping data inside Redshift, but it might happen because remember that now, let's take a step back. So Redshift, if you look at the traditional way of deploying Redshift, your storage and your compute comes together, right? Now with RA3, you can segregate it, but I will keep that topic for some other time. Okay. So your Redshift compute and storage comes together. We're talking about DC2 or DC or DS instances. And sometimes when your storage is full, so probably your storage has overloaded, but your compute requirement is still okay. And in that case, you will add another node to the cluster for the additional storage. Of course, you get additional compute, but probably you don't need additional compute. You're happy with your compute. But you're adding an additional node to the cluster and paying for additional node because you need more storage. And that is where, again, you can use Redshift cluster with S3, where generally I've seen that people try to keep their latest warm data into Redshift and their offload data or cold data that go into your S3 bucket. So they say, okay, fine, I have some data into Redshift, but my most of the queries are on this data set only. The rest of the data I occasionally query. So in that case, what you can do is that your frequently accessed data, your warm data, you can keep inside Redshift, and rest you can offload to S3. In that case, you are not worried about your storage getting exhausted, because generally your query data is limited data that is not ever increasing data, because the whole with the time your latest data snapshot changes, but your amount of latest data, warm data remains the same amount. So you don't need to add additional node, and you're not worried about your storage getting expired, because whenever any data becomes from warm to cold, you simply push that to S3 bucket, and you can keep your nodes, your cluster size as you have. So this is the second scenario I have seen where you can keep your warm data inside Redshift and keep your cold or offload data into your S3 bucket. So if you have scenarios like that where you want to tier your data between S3 bucket, storage tier your storage between S3 bucket and Redshift, then Redshift Spectrum comes to help, because then it enables you to tier the data, enables you to query the tier data, not enables to tier data, but tiering you do yourself by segregating your data in two different storage, S3 and Redshift. But Spectrum enables you to query the data from Redshift, which can fetch data not only from the Redshift but also from Amazon S3. So let's learn a few things about Redshift Spectrum. So when I talk about moving data to S3 and not adding any additional storage, that sounds like, okay, wow, I'm going to save good cost. And yes, you're going to save some good cost, because of course, I mean, you don't need to add an additional node just to get additional storage. But there are two factors which work here, and you need to understand. And based on your use case, these two factors you should use in your cost modeling to decide how much you're going to pay for this solution. So offloading to S3 doesn't mean necessarily your cost will reduce. So you have to keep these two parameters in perspective. So one parameter is, of course, when you're offloading your storage to S3, so you don't need to, suppose your storage, you don't need to buy additional node for the storage. And in that case, of course, you're not paying for that additional node, so your storage cost, your compute cost reduces. But at the same time, when you're trying to query data from S3, there's a charge for that. And the charge is not like it's going to derail your budget, but it's like $5 per terabytes of data scanned. So if you are, so per terabyte of data you scan, you pay $5 for that. So depending on how many queries are going from Redshift to S3, and how much data is scanned for that query, you have to pay for this. So there is a query cost. There is a query cost involved. When you have data inside Redshift only, there is no query cost. You only pay for the Redshift cluster, and you are good. But if you are putting your data, offloading your data into S3 bucket, then in that case you are paying for the query of the data. So in your business case, you have to see that by offloading your data to S3, this whole joint cost, how does it look like? I mean, so that's something to take care of. I mean, there's no golden words that how it should be used, but yeah, each use case should see that if I choose to offload my data to S3 bucket versus adding one more node of Redshift cluster to enhance my storage, let's do the cost modeling based on my usage, based on my queries going to S3 to determine how does the cost look like. Okay, so that's very important. Another very important thing is that when you're keeping your data inside S3, try to keep in such a format that the least amount of data is scanned. So very simple example is that if you're trying to keep data inside, say, in a JSON or CSV format, then your data scan is high. If you decide to use some kind of columnar format like Parquet, then in that case, the amount of data scanned is low. So that's also something you should keep into your design consideration, that when you're keeping your data inside S3, try to keep in such a format like Parquet where even if the query goes to S3, the amount of data scanned to get the result is less than other formats like CSVs or JSON. Okay, so let's move forward and see how it works. So it's very simple, guys. I mean, if you hardly take, hardly 15, 20, all time it takes is to launch a Redshift Spectrum. The rest is simple. So first of all, you need to create an IAM role and assign it to Redshift cluster. And why we need an IAM role? Because now Redshift cluster is actually, so you make a query to Redshift cluster, and then Redshift cluster is making query to S3 bucket. And when it makes query to S3 bucket, it uses some other services like Glue and Athena. So it needs to have permission to be able to call S3, Glue, Athena. So this role provides that permission. So there's certain recommendation how you can configure permission for this role. And when you do that, actually your Redshift cluster will have permission to make query to use this role to make query to S3 bucket using services like Glue and Athena. The second one is you create an external schema inside Redshift. So you create an external schema. And this schema you create, so when you create external schema, actually what it does is that behind the scene, it also creates a database inside Glue. So when you make query through this schema inside Redshift, actually the query brings data by fetching data from the database. Okay, so I will again explain it more when I show how the query look like to create external schema in the coming slides. Then you create an external table in this external schema. So you created the schema. Now you're creating a table under the schema. And this table is configured in such a way that it is pointing data, it is bringing data from the S3 storage. So it's not looking for the data inside. It doesn't have a data stored inside a table in Redshift, but it is bringing data from the S3 storage. And for that, it uses Athena external tables. So the database you created in the step 2, it creates in step 2. You don't create, actually you create a schema and it creates database in Glue by itself. In the same database, this external table is also created in Glue. So when you make query to table in the schema, in the Redshift, actually the query goes all the way to Glue table in database to fetch the data. And finally, once you have created the external table, you simply go and query the data. So let's see some of these things. How do we create external schema and external table? So that will give you more sense about how this whole thing works. So let's go to the next slide. And by the way, just to repeat, query table. So when you make query table, now you have you have a local schema in Redshift. You have a local table in Redshift. All you have to do is simply make query to table like you make query to any other table inside Redshift. So there's no difference in that in terms of how you query it. So let's see how external schema works. So this is the typical syntax of an external schema. It is saying that, hey, let's create an external schema. This is the name of the schema. And then saying that you're creating it from the catalog. That means saying that, okay, when I create this schema, create a database with this name into Glue data catalog. Okay. And then this is the role we are using to authorize permission. So this is the same role we created in the earlier step, and which has permission to talk to Glue, Athena, and S3. I'm saying, okay, let's create external database only if it doesn't exist. Okay. Otherwise, if it is already there, don't try to recreate it. So when you run this query, what happens is two things happen. First, a schema is created with this name, Spectrum schema in Redshift. And then a Glue database is created, like the Spectrum DB in your Glue. Okay, so two things happen. So this schema is in a way linked to this Glue database. And similarly, when we create the table in the schema in the schema will be linked to a table inside Glue database. And that's how when you make query to the Redshift, query goes all the way. It's like an Athena query goes all the way to Glue to fetch data from S3 and pass back to Redshift. That's how it works. So Redshift behind the scene is using Athena query to bring data from S3. But you don't realize it because for you, you're making a simple query to a table inside Redshift under the schema you have created. So now that you have created the schema, you create the table, and flow is pretty simple. The query is pretty simple. So create external table. This is my schema name. Okay, again, it's different from previous one. I took this examples from the AWS website. So yeah. So this is the schema name. This is the table name. This is the columns and their schema you are providing. Then saying, okay, I'm reading it from this location. I'm reading it from this location. It is stored as a text file. This is my field delimiter. This is my row format delimited. So yeah, so you're simply saying that, hey, create this external table, but actually source of my table is this folder where I have my data to fetch from. So why I'm providing a folder? Because under this folder, I can have one file which can have my data, or I can have my data in different partitions. And in that case, it will aggregate data from different partitions to fetch result for the query. Again, what happens behind when you run this query is that one table sales get created inside this schema, which you have just created in the previous step, and then another table sales get created as a glue table inside the glue database, which you created in the previous step when you create the schema. So again, in terms of mapping, the table you create inside the Redshift gets mapped to table schema created inside glue database, which is actually pointing to data stored into S3. So when you make query to the sales table under Spectrum, actually it will go and make Athena-based query to the glue table under the glue database to fetch you the result from the S3 bucket. That's how simply it works. Yeah. So having said so, what are we building today? So what I'm building today is pretty straightforward, guys. It's very small exercise. Is that we will have Amazon S3 bucket where we'll keep some sample CSV data. Then we are going to launch Amazon Redshift, and then we'll configure we use Redshift Spectrum to configure the external schema and table, and then we simply make query to that S3 data using that external schema and table. It's pretty straightforward workshop exercise today. So in order to do the work exercise, we have uploaded exercise to our website aws-dojo.com. This exercise, the URL of the exercise has also been provided in the description box below. And now what I'm going to do is explain how this exercise works step by step. And after that, you can run this exercise by your own, and implement the scenario by yourself to get an experience of it. Okay, so without losing any more time, let's jump to the exercise. So here is this exercise uploaded to our website aws-dojo.com, and there are many other similar exercise and workshops uploaded over here. Each of them implement a certain scenario, and by doing so, by implementing those scenarios, by this step-by-step process, you learn about AWS services. So please do try out. But let's focus on this exercise today. So these are the steps you have to perform. So first step is that you need to have an AWS account, and if you don't have an AWS account, you might want to use this link to create one trial account. Then we have a sample data.csv, which we have really a dummy data, which we have simply provided a link over here to download the data, but you can bring your own data if you want, to be very honest. And what we are doing here is that we are going to the first S3 Management Studio. We are creating a bucket called Dojo Data, and in that we are uploading this sample data.csv file, which should be downloaded from this link. Yeah, so just simply did that. And this is how the data look like. I mean, I'm simply putting some country name here, and second one, I'm saying it's the business index of the country. But to be honest, it's really a very dummy data, nothing more than that. So this data you upload to S3 bucket. So this is the data you want to query into your Redshift spectrum. Next step is to create an IAM role. And then for that, we simply say, go to IAM Management Studio, roles, want to create a role, and then you select this option that you want to create a customizable role for Redshift. And then you want to give the permission. In this case, I'm giving this power user access permission, but if you're going for production implementation, you might want to give very specific permission for Athena, Glue, and S3. And there's a good documentation about that in Redshift Spectrum documentation from AWS. You can use that, but I kept it pretty simple just because I want to demonstrate more on the Redshift part than security part here. Okay, so we move next and say, okay, fine. The name of the role is called Dozo Redshift role, and we simply create the role. So role is created, which Redshift cluster is going to use to make query to S3 data using Athena and Glue. So now we create the Redshift cluster. So we go to Redshift Management Console and say we want to create a cluster, and then we give it a name called Dozo Redshift Cluster. Simply use a free trial configuration so that we don't incur much cost here. And then we are giving database name dev. Port is by default. And then we say, okay, my AWS user is the default username. And I use the password one exclamation as the password. So you configure that. And then you need to do one additional step, which that I want to assign this role to the Redshift role to the Redshift cluster. So you go to the cluster's permission section, select this role, create on this IAM role button so that this role gets added to the Redshift cluster when creating, and then you simply create the cluster. Click on the create cluster. And it will take some time before the Redshift cluster is ready, and you wait till the status changes to available. And here I have provided again some of the key things you need to know to log into Redshift cluster for query. Now let's go to the next step, which is trying to not insert data. Okay, that's the wrong title. I'll fix it. But yeah, basically you're trying to create the schema here. So what you do here is that you go to the Redshift cluster and say, I want to use the editor, query editor. So you click on query editor, and then you provide your login and password, and it goes in. And to be very honest, I have seen some of the latest changes where it simply uses temporary credentials to go in. So probably you don't need to provide login and password as well. But I still provide it here, making sure that at least this method will work for you for sure. So now what we do is that once we have logged in, we run the first query. And the first query is that we want to create an external schema, S3 data schema, and then we are saying that the Glue database which you create should be named dev, and then here we provide the IAM role ARM. So when you created the IAM role, actually I asked you to make a copy of the IAM role there. So you provide that IAM role ARN over here, and then you run the query. And when you run the query, what happens that you can see when the query execution finishes, in the Redshift, it will create an S3 data schema. And actually, I have not shown the screen over here, but if you go to the AWS console, Glue console, you can see a dev database created over there. Now my schema is ready. I need to create a table. So I run this second query where I'm saying that in this S3 data schema, I want to run this country business index, create this country business index table. This is my schema of the table. So first one is the country, second one is the integer, and then my file is stored into S3 Dozo data. Remember, this is the S3 bucket we created and uploaded our data file, and then I provided whole delimiting information over here. So when I run this query, actually what happens is that under this schema, S3 data schema, it creates a table called country business index. And again, I have not shown here, but if you go to the Glue console, you will see that under the dev database, uh, you will have this country business index um, created. Okay, so pretty simple and straightforward. So now my table is created, and guys, that's it. Job is done. All you do is simply go make query to this table, and when you do so, it will Redshift cluster will simply use Athena to make query to the S3 bucket using Glue. Okay. So let's see how it works, and it's pretty straightforward. So select star from S3 data schema country business index. You run this query, and guess what? Within your Redshift cluster, you are actually getting the result back. And this data is coming all the way from S3 bucket. So pretty straightforward. So that pretty much finishes this exercise. Next step is to go and clean up the resources so that you don't incur any cost post this exercise. So hope you like this exercise, guys. And if you like, please click on the like button. Please subscribe to my channel. As I mentioned earlier, there are many other similar workshops and exercises which you can use to learn about AWS services. If you have any feedback, comments, or any request for new content, either you can provide me in the YouTube channel comments section, or you can also click on this contact us tab and can provide feedback from there. So we always look forward to your feedback, especially for the new content and improving the quality of our work. So yeah, we look forward to you for that. And I promise to come back again with another such video in the coming days. Meanwhile, please stay safe and have a nice day. Bye-bye.